Hey everyone, it's Mr. H here. We're going to continue with 6.4 and we're going to do some graphs using the tool in MyLab, which is how you'll be doing graphs, so you won't have to do them by hand, but you'll use some technology. So here's an example. It's easiest just to show you with an example from the homework. This is something like number 16 on the 6.4, and you want to graph that function. So what I like to do is click to enlarge the graph. And once you do that, then you have these features here. Okay, so notice there's two options. You have that option and that option. This is the sine wave. This is the cosine wave. So look at your function, and if it's cosine, use that one. If it's sine, use that one. So I'm going to click that one. Okay, and then I'm going to just plot a point. Right? It doesn't even matter if it's right. Just click the graph somewhere. I just put 0, 0. Okay, and then it's just going to give you the standard cosine wave. But then this pops up, and that will allow you to input the amplitude and the period, vertical shift, and phase shift. Okay, that's pretty much how it's done. So for my amplitude, the default is 1. So now I have 2. I gotta move it over to 2. Just make sure it says 2 in the little window there. When you click, I'm clicking and dragging, right? Okay, so I got my amplitude correct. For the period, it should be 2 pi, right? Except if I look at my function, the coefficient is 1. So that's correct, but I could just shift that around. It's just an interval deal. All right, so 2 pi is right. Vertical shift is 0 because there is none. Phase shift is pi over 10. So I'm going to get rid of that 0, and I'm going to put positive pi over 10. To input pi in this, just put pi. So pi, and it changes it to pi. And then I hit divided by, which is below the question mark on my keyboard. And then I put in 10. Okay. And then I would just click on x-axis reflection if there was a negative out front. But this one doesn't have that, so I'm good to go. I just hit enter and then save. All right, I like it. Looks like a pretty graph to me. Right now I've got it here, and then check answer. Woohoo, did it. Okay, let's try another one. Maybe one that has a little bit more going on. Whoa, that one does. Okay, so I'm gonna click enlarge graph. Let's see, we got sine wave. Click on the sine wave. Plot any point, just click. That'll just bring this up, and then you can get it right. Okay, and then you're inputting the correct values. Ooh, 3/2. It's only going to want decimals here. So my vertical stretch, 3 divided by 2 is 1.5. So I'm just going to click and drag it over, right? So I hold down and hold down, the click on my mouse and move it over. That's what I did. Okay. The period is 2 pi over 4, which reduces to pi over 2. So I got to move this over, click and drag it. There's pi. So pi over 2 would be right between 0 and pi. You can verify that with a decimal. Pi divided by 2 is 1.57. Okay, so I got the period correct. Vertical shift, there's none. Phase shift is that pi over 6, but it's to the left. I'm putting negative pi divided by 6. Enter. All right, and then that's adjust it. I like it. Save it. Check it. Did it. Okay, so that's how that works. You got to play around with it a little bit and get used to it. But as long as you're getting the amplitude, period, phase shift, and all those correct, and you put them in, it should work out pretty nicely. All right. Okay. The last thing I'll do is a word problem. So we're going back to the handout for this one. And we're going to look at this problem, which is on the last page of your 6.4 notes. We have monthly temperatures. Average monthly temperatures in New Orleans is the max is 83 and the minimum 53. And then there it is. And then we've got a little computerized scatter plot with a 2-year interval of temperatures, okay? Which then we can look at the pattern there, and it definitely looks like a periodic pattern. You can see it as a sine or a cosine, depending on where you start. You'll see both patterns. But we can start answering some questions about this data. Part A, do the data seem to indicate a translated sine graph? Sure, right, I could see it. If I started here and went, whoa, just not liking my curvy there, right? I see a sine wave there. That would be a inverted sine wave, right? I could also see cosine waves. Okay, but yeah, it definitely is a sine graph. That means I can use sine to model this graph. Okay, or even, that was probably bad. What if I did, maybe you were like, why'd you do that? But what if I just started here? That's better, right? There, then it's not negative. Okay, approximate the amplitude. Okay, if you have data and you wanted to get an amplitude, remember amplitude is half the distance from the max to the min. So what I'm going to do is take the maximum, 83, subtract the minimum, 53, and then divide that by 2. So that'd be 30 divided by 2. 15 is my amplitude. Okay. How about the period of the sine wave? Well, this is a 2-year cycle, and the x-axis is labeled in months, right? So each cycle should be 1 year or 12 months. So the period is 12, because it's 12 months in a year, right? So every 12 months, we'll get a new cycle. The vertical translation should be the middle of the graph, right? Where is that? And that's pretty much the average between the max and the min, right? So to find that vertical translation, you can take 83 plus 53 and divide it by 2. You're finding the average between the max and the min. This is 136. If I add those together, hopefully I did the math right, 136 divided by 2, which is 68. There would be your vertical translation. Okay. Approximate the phase shift, or that's where does this graph start? Okay. So the coldest temperature is when x is equal to 1, right? Because that's where it starts. I guess I didn't write that, but you'll see that in the homework. It'll start this. I should have put that x equal 1 for January. And then the 7th month is where you reach the maximum for the first time, even though August is the same. But the 7th month is July, where you hit your maximum. So the starting point, your phase shift, this value should be right between 1 and 7. So I would average those together for your phase shift. Do 1 plus 7 divided by 2. And that's 8 divided by 2, which is 4. So your phase shift is 4 units to the right. Okay. Finally, we can put all those in to find the model for the graph. So I need A, B, C, and D. So A is 15. That's the amplitude. 2 pi over B should equal the period, just 12. Right? So if I solve that for B, I would multiply both sides by B. I'd have 2 pi equals 12B. So then 2 pi over 12 is equal to B. Right? And so B is equal to pi over 6. Okay, that's the hardest one. C is the vertical translation, right? Because that's that number out front. So in this case, C is going to be 68. And then finally, D is the phase shift, which we found to be 4. Put all of those together in this form, and you'll have the model. So we're going to have f of x equals c, which is 68, plus a, 15, sine, bracket, b pi over 6, parenthesis, x minus 4. Okay. And we've got it. That's the end. Okay. And this would do a very good job of modeling the data. If you went and used a graphing tool and graphed this, it would look like this model here. Okay. You could play around with your graphing calculator if you have one and try that. Graphing calculator not required for this class, but if you have one and you want to try that out, go for it. I think there is a question on this problem when you get to it about, do this in your graphing calculator and compare. You don't have to. You can get that problem right just by comparing this, by using this, right? So you don't necessarily need a graphing calculator for that problem, but just to warn you, it does mention a graphing calculator. Don't let that scare you if you don't have one. You'll be fine. Okay, so that's the end of 6.4. Hope all is well. Talk to you later.